it looks like I'll be here for at least a year, which means I'd like to get this thing off the ground. And we're forming a small team in San Diego to take it forward. And the super gun that we ran in the 90s is actually about 2 miles from here. It's in Kearney Mesa. So it's in storage. The Air Force has it on a crate with us, with our company. We may use that for phase 1, but we don't need to. I can run another system for phase 1 that doesn't cost too much. We can build it out of composites, which is my preferred material. Steel and graphite is my preferred anyways, because that segues really nicely into the one you saw in Popular Mechanics, the neutrally buoyant version. The one we have now would sink like a rock if you put it in the ocean. It would take the ship down with it too. Yeah, you basically tow it out to the equator, just like they currently tow out the sea launch, stuff. And it's a couple weeks out of Long Beach or wherever you're going, and then you're set up at the equator. And there's a mothership, within a mile or so that's making sure everything's copacetic, pre-shot, post-shot. So
mission control.
Yeah, and you have your team of maintenance guys there because you don't want to be anywhere near this when it fires. It's there's always a chance someone will go wrong. Plus, there will be a shock wave within a few hundred meters. Yeah. Yeah, it's a little percussive there, but the nice thing about it is, when the sound waves hit the water, they bounce off. There's an impedance mismatch, so only a small fraction of the sound actually gets into the water. Yeah, it's because impedances of air and water are about 1,000 different, factor of 1,000 apart, and the reflection goes like that, the square of those numbers and stuff. So you don't couple much of the energy into the water, and we'll do a sweep. We'll make sure no cetaceans are within okay, I'll give you 2 miles. 2 mile keep out for cetaceans. We'll let the lawyers in really close and just tell them to put their hands in their fingers in their ears, okay?
So how close will
right at the muzzle.
How close will, say, the support ship be to this launch?
It's got to be several hundred meters at least. We typically we did open air shots where we had observers at 1,200 feet.
Which is pretty close.
Yeah, but that was with a much smaller system. That was with the 400-foot long gun. That was super hard, okay? So in the real issue is not the acoustics, it's the possibility of shrapnel. Because let's say you have an issue, you have a vehicle breakup in bore, which shouldn't happen. But if it happens, then the muffler disassembles, and you have pieces of high-strength steel flying all over the place. They typically fly about a mile or two, okay? So to keep everyone safe, you'd have a keep out of a mile. We had a 3,000-foot keep out at Livermore, 3,000-foot radius, which we would control all the gates, and we turn the buzzers on, the alarms on, and sweep the area, make sure no civilians are inside, then we go underground for the shots. Sharp was a fascinating project, and this is going to be even more fascinating because this is the true goal. The true goal is you want to get up into the blue, and you want to be able to service things that happen to be orbiting at 7.6 kilometers per second. Just a gas station. We want to put up a gas station in space. Because once you got the gas station, the guys will stop sending their Cadillacs, they'll start sending their Chevys and their Fords. Right now we send these caddies, they got 1 tank of gas, they go across town a few times, run out of gas, and they're junk. Okay, that's the true story of space. So, because they only have, they spend $5,000 to $10,000 a pound for the propellant. You can't afford to put a lot of propellant up there. So they run it once, they junk the caddy. Or else it sits there very quiescently and the guy gets to turn it on for 10 seconds every couple months just to make sure it still starts.
So for the average Joe, like myself, how high can you really shoot this stuff? I mean,
oh, well, you sort of like, low orbit is considered, 300 kilometers or so, sort of space shuttle type numbers. And, but you can launch it all the way to geosync. Because what happens is we launch a single stage rocket. This always has at least 1 stage rocket on it. So it comes out at 6 kilometers per second. You lose about half a kilometer per second is the atmosphere and the gravity scrub it off, okay? So you're down to 5.5 clicks at 100 kilometers, 5.5 kilometers per second. And then it does a gravity coast. And you turn the rocket motors on, say at 450 kilometer, when it's getting close to apogee. You turn them on, they run for 100 seconds, and you achieve orbital rendezvous with the station. So that would be a low Earth orbit depot. But you can also put depots in geosync. Same thing would happen, and you can even do a lunar depot. Because the lunar depot would be one you'd use to supply guys, in the vicinity of the moon. But you want to start with your first step is LEO. And then if you want to go to Mars, LEO's not a bad place to stage from. There's other you can stage from geosync and all the other places you can imagine, but it does work. LEO works for staging for Mars. So you'd assemble 1,000 tons of propellant in LEO, and over a year or so, and then the customer, which presumably would be NASA, would come in with their vehicle which doesn't have any gas tanks filled, and we would basically fill it up.